So please somebody confirm that you can see the slides. Doesn't look like that, but you can still hear me? Oh, okay, good. Mark just confirmed. So you hear me and you can see the slides. Yes. Okay, that was just a single yes. Okay, now we got the second yes. Thank you, Mark, for that. So I announced that we start on 1 minute after 4. So a few people have joined. Thanks everyone for joining Monday afternoon at 4 p.m., which is COVID webinar time. This time it's already the third time that we are running this webinar. So I do have a two screen setup. So sometimes I look at the bottom screen. So that's why you see me looking down sometimes. But I try to look at the camera, which is on the top screen as well. So welcome everyone to the third webinar, which is about self-service for developers. So we are looking at how we can deploy modern apps, including pipelines and operations orchestrated by Proton. So Proton is quite an exciting new service from AWS that got launched about a year ago, and COVID has started to dabble with Proton around the release time, and we have set up quite an interesting demonstration, which I'm going to show you today in the next 45 minutes or so that this webinar will run. So for those of you that have that participate the first time here in this webinar series, I would like to give you an introduction of who Copit is and also, of course, who I am, so that you know who you are listening to. So Copit AG is an AWS Advanced Consulting partner. We have been around for roughly 5 years. Oh, actually, it's more than 5 years. So we had our 5th birthday a couple of weeks ago. When we got founded, and Copit is actually focusing almost entirely on AWS containers and Kubernetes and automation. And of course, with that also comes cloud consulting. And we also have our CEO very interested in IoT. So we also run courses in IoT and educate quite a few students on IoT topics. In total, Copit is now 15 employees. So we are actually growing quite quickly. Today, we also have a new employee in here. You won't see his name because it is all hidden, but we do have also a new employee joining actually next week, and he is already participating here in the webinar. Welcome, Marcus. I won't say more than just the first name. There are many Marcuses here in Switzerland. So my name is Marco Kündig. I'm the CTO here at Copit and have been around for roughly 3 years. So my third anniversary is coming up in November timeframe, and I have been in the cloud space for a number of years now. So I believe I started doing public cloud stuff in 2015 when I moved to Australia. I spent there 3 years and have worked there with 2 AWS partners and learned there a lot about public cloud. But in the cloud space, I have been 8-10 years probably with the private cloud things, and have seen quite a few things in the cloud area in that time. So I have been a partner at Copit since 2018. I also invest quite a bit of my time into certifications. So 8 AWS certifications by now, including 2 DevOps, including 2 pros, 1 DevOps and 1 SA Pro, and 2 specializations, and all the associates and other things. I've also done 2 Kubernetes certifications with CKA and CKAD. So those have been challenging as well. On previous lives, I did VMware and Cisco stuff, and I have worked over my career with AWS, GCP, and Azure. So I know my way around in the public cloud space. So that gives you a bit of an introduction of who we are, who I am. And now we are looking at Proton, what Proton actually is. And when AWS launched the service at reInvent 2020, I believe, I got very excited about it. And the reason for that is we have been using the AWS Service Catalog for probably 4 years now. And I personally have used the AWS Service Catalog for 5 and more years. In Australia, we have used that quite a bit. And when Proton came out, I started to see the advantages of Proton in the self-service area. So the normal AWS Service Catalog is actually more on infrastructure as a service. So with that, you create RDS instances, VPCs, VMs, of course. Of course, you can also do containers, but it is never as flexible and never geared towards developers as Proton is. So basically, Proton was developed for large enterprises that wanted to automate a lot of microservices deployments. And what you see in most cases in enterprises is that you have a platform team. So the platform team actually is usually the cloud team that is responsible for the platform, and they know exactly what kind of cloud services are allowed in the organization. They know how to use these cloud services. They know the policies and the compliance requirements that they have. And they also know how to write platform-specific code with CloudFormation, for example. And what they do is they put these services into the platform catalog. So the platform team they write these CloudFormation and change templates, and they deploy it onto Proton. And then they also deploy the environments. I showed you that later on, how that is done. And they also actually not only create the environment templates, they also create the service templates. So these service templates, they are actually used to define what a microservice consists of. So, for example, ECS Fargate containers or AWS Lambdas or Kubernetes in the future, Kubernetes deployments in the future. So these service templates, they can be almost anything that AWS supports, but it is very much geared towards containers and serverless solutions. And then they publish these environment templates and the service templates into the catalog, into the Proton catalog, and then the developers can go and actually consume these templates. And they usually consume the service templates and then start to parameterize those according to the needs that they have. So the platform team could have deployed, for example, for a Java application, a Java containerized application, service templates, and a Java developer could go and pick one of these service templates and launch his new microservice into the required environments that the platform team has deployed. So that's the overall framework of Proton, what is done. And now I show you how that is actually used in actual daily lives. So as said before, we do have the platform administrators. So the platform administrators, they do the top part. So the top part is the environment templates. They stage the environments, for example, staging, development, staging, production, and they also create the service templates. And then we got the developers, and the developers, they can go and consume a service template that has been published, and then then instantiate the required microservices based on these templates. And now these templates are executed, new service instances are coming up, and then actually the source code gets published via the pipelines. I'll show you that later on in the demonstration. And then actually the end users, they can very, very quickly start to consume these applications deployed to the various environments. So what you need to remember in the Proton world, oh, thank you, Graham, for that comment. Yes, that's right. So Proton is quite a new service from AWS, and there needs to be a lot of evangelization so that people start to understand what Proton is really about. And that's why we have started this webinar as well, because we are so convinced that Proton is a really cool thing to help the platform folks as well as the developers to move much quicker and without making a mess in these environments. And that's one of the biggest enablers of Proton, because everything is template based. That means it is out of the box automated. And because it's automated and based on templates, it is actually highly standardized. So the developers, they consume these templates. It's super easy for them to start new microservices. And the platform team has assurance that actually only the services that are in the catalog can be consumed and are provisioned in an automated and highly standardized way. So what are we actually building with Proton? So as mentioned before, we have been using AWS for a long time, and we have deployed things that you see here on the slide set on this architecture before with CloudFormation in the classic legacy way. So we did have CloudFormation templates for ECS task running on Fargate. We did have App Mesh CloudFormation. We had ALB, Route 53, ACM templates. We did have monitoring templates. We did have pipeline templates. So based on the CodeStar suite with code pipeline and code build and code deploy and all these nice features. And of course, we had branching methodologies linked up to these pipelines. And when we stood up a new client, what we actually did, we took all these CloudFormation templates and started to parameterize those for the specific client to stand his application up. And that could be for 3 environments, for 10 microservices, so 30 instances in total. So that gave quite a bit of parameter files that we had to look after. And if we were lucky, we could use a single service template. But as you know, in many cases, the clients, they're using multiple different programming languages, multiple different deployment methodologies, and then it started to become messy, and these infrastructure as code repositories became quite difficult to handle. Even if everything was based on infrastructure as code, it was still a lot of bash scripts and template files to maintain and look after. And with Proton, we actually can have a very automated and standardized way. So we are putting in the environment templates, we are putting in the service templates for the languages, and then Proton can parameterize these things as required. So we actually have here in this architecture that you see, we have from the developer workflow, so from the Git flow to the pipeline to the execution to the traffic routing and monitoring and the serving of the application, everything templatized in Proton templates, which are based on CloudFormation and the Jinja language. Jinja is probably something that you have not heard so far, because that is quite Proton specific. And Jinja is actually a scripting language which allows the operators to change these CloudFormation templates on the fly. So you have a standardized templates, and you can put in these changes with the Jinja language super easily through a bit of specification with a specification file. So a tiny little code that defines what needs to be changed in these CloudFormation templates with Jinja, and then off it goes, and or Proton hands it over to CloudFormation and executes all these CloudFormation templates as required. So you see here, everything is orchestrated via Proton, which is an orchestration engine. And then we have also for monitoring, we do have DevOps Guru involved that actually listens on anomalies that happen inside of the environment and help us to monitor the environment. So DevOps Guru has nothing to do with Proton. Proton is orchestration, DevOps Guru is monitoring, but we have integrated it because it makes a whole lot of sense to use these two services together. Good. So that's the whole thing that we have built. We're actually quite proud of what we have built, and we also got some great recognition from AWS for what we have built together with Proton, because we have been an early user of Proton. So we started to use it in preview mode. AWS supported us quite a bit, and actually we were one of the launch partners. And if you Google for AWS Proton and Copit, you should find that GA announcement of AWS in Seattle. And we are actually quite proud that we have been one of the very few partners and customers of AWS Proton in Europe, actually, that got mentioned on that Proton launch. And actually, I gave a presentation to the AWS Proton team last Friday, and got some great feedback from the AWS Proton team on what we have built. And because we have such a close working relationship with these Proton developers, we could also give them some feedback what they could enhance and make the life of a developer even easier. Good. And now, actually, we are switching over into demo mode. If you have a question, just please type it into the chat window. I try to look at it from time to time. Everything clear so far? Good. And then now it becomes interesting. It's a live demonstration. I'm not showing you a canned video. I'm actually showing you a live setup that we have done. So because everything is highly scripted, a quick question, can please somebody type in that you see now the AWS console? Yes, great. Thank you, Mark, for confirming that. So here you see an AWS Proton environment that is running in Ireland. Because it's quite early for Proton, not all the regions are yet enabled with Proton, but I believe Frankfurt has been enabled as well. But because we have been an early user, we mainly used Ireland, because there we know that we always have good and recent versions established. So because everything is scripted, I actually launched two. I actually will do two. Okay, thank you, Reto, for that confirmation. So you need to use Ireland then, or of course US East one, which always has all the latest technologies available. But I know that Proton should come soon in Frankfurt, because we have requested that. So because everything is scripted up, but I don't want to have you wait, I have provisioned two environments. So one environment that is already provisioned is the development environment, and that is what I will use for the demonstration. But I want to show you how easy it is to get the same environment up and running again with a script that we have created, and that's a Copit CI now. And what I will do is I will launch the production environment. Development is already here, but that you see that this stuff is coming live through, and nothing is faked here. So this script here will now do the basic the deployment necessary. So first, it creates a role, because it's AWS. It always needs roles, and it needs quite a high privilege role to do all these things that Proton will use. And then it actually starts to push templates, because I have already pre-prepared the development environment. The templates have already been there. So the environment template and the service template have already been pushed before for the development environment, and then it starts to build up an environment for production. And now I switch over into into the AWS console. So what you see here is the environment template. So we call that a Proton cluster. And I don't show you the code. The code is basic CloudFormation that we use. So here you see we do have the environment template. It is versioned. So meaning even if you do changes, you can actually apply a version, and then your platform team can deploy various versions. And of course, you can also upgrade environments that you have created. So you see the development environment has been created almost an hour ago, and even more than an hour ago, to prepare for this webinar. And the production environment is coming up right now. And actually what the environment does, it actually starts up an ECS cluster and some roles, and it configures the ALB things that we need, so that a base environment is here. And it also puts in DevOps Guru, and it puts in RDS databases and stuff like that. That is coming up. And because that takes time, I have already one environment up and running for you. And then the service templates is also deployed from the platform team. So the service template actually is defining the pipelines, the containers, the CloudWatch monitoring things, the ALBs, the ACM stuff. All of these things are defined in the service template. And same as with the environment templates, you can use versions. So meaning if you do changes, you can upload a new version, and then a development person can actually go and upgrade his service instances to the new version as well. And that gives a lot of power, because you got these versions that work really well, and all is based on CloudFormations, which can do updates. You actually have a full life cycle of the infrastructure as code templates established as well. And as you see now, we have these two environments up and running, and now the services are coming up. So what we do, we actually have these 4 microservices. So this demo application consists of 4 microservices. It basically has a gateway to connect in. It got a fetch microservice, it got a delete microservice, and it got a create microservice. And because we are running this in 2 environments, at the end, we will have 8 microservices, including pipelines and executions, all in here. And because we don't want to wait, I show you now what has been established before. So you see, everything is based on CloudFormation. So for each service instantiation for the application with 4 microservices, Proton will launch 4 CloudFormation templates for each microservice, 1 for the containers and 1 for the pipelines that we are using based on the CodeStar suite. And if you want, I can show you what is in here. Here, that's the pipeline file now. Here you see that's the actual executed CloudFormation template that is used. And that is all the same for all 4 microservices, even if we have been using Node.js and Python mixed for these 4 microservices. So here you see you also can debug and troubleshoot these applications on the CloudFormation level. So it's not hidden. So it's not some magic that is super hard to operate. So if you got an error in your templates, you see that here in CloudFormation. So you see these events popping up, and then you can actually do something about it and do the changes necessary. So now let's go into ECS. So the application that we are using here is containerized, and it's actually the compute is running on ECS Fargate. So let's go out. We should actually see now 2 ECS clusters. So that's what we see. you got the development environment, and you got the production environment, which is actually building up with what I have executed before. But we will focus for now on the development environment because that's fully executed. So here you see we got 4 tasks running for those 4 microservices because that's a stable environment now, and the application is actually running and executed here. So you see the 4 services, and you see the 4 tasks. One of them is rebooting. I've forgotten there, but that doesn't really matter. I can show you what's going on there as well. So let's go back into Proton, and we want to see the service instances. So the service instances are actually executed service templates on environments. So what you see here, we should see 7 by now, 4 for development and 3 for production, because the 4th production will come later on, because that's the gateway plugged in front of the environment. What we will focus on for this demonstration is now the fetch service. That's actually the one that is reaching out into DynamoDB. Now, actually, it's Postgres RDR that we're using in here. And actually, this one here will go and read information out of DynamoDB. But that's not the focus of the demonstration. It's just to show you that it all is coming up. And here you see the ALB that has these configured. So the endpoint, which is now based on ALB. So AppMesh is not a part of this demonstration right now because AppMesh is super complex, but we have built AppMesh things as well. So for now, we are using blue-green with an ALB as the endpoint. So if I go onto that ALB service endpoint, that's actually the ALB, and that one here is exposed to this here. And so that you see, this is not a fake. I will reload this one. So you see fetch task def running in 9.1.12 account in Ireland. There is no ACM certificate on it, but that could be done easily as well, fully scripted based on ACM. And now, actually, when I deployed that application, I actually linked up the pipeline with a repo. So actually, each microservice is hooked up to a repo hosted on GitHub. And because it's a pipeline, I want to show you now how the pipeline is executing. So you see right now is running version 1.0. And I go in and do a change. That's a super easy change. I commit that. I should also put in some commit message. I'm not doing that right now for this demonstration. And what happens now, it actually triggers the pipeline that is already here. So you see, I did a change on the fetch task, and that has now triggered the pipeline. So let's look at the pipeline, which is also fully configured via the Proton setup that I have launched about an hour ago. So with that commit that I have done on GitHub, it triggers actually the source stage. The source stage is nothing more than just a trigger. It actually listens on GitHub and senses when there are releases or commits coming in on GitHub. Then it starts the build process. And actually the build process, we can look at it, what actually happens here. So you can see here in a very easy way and a very cost-efficient way as well, how these pipelines are executing. So no Jenkins necessary, no other Circle CI expensive tools necessary, no build instances. So that's all container-based. And for this pipeline, what we actually do, we put in a bit of tooling. So we install the AWS CLI, we put in the SDK, and as soon as that is done, we download some tools. Don't worry about those things. And then we start to configure the actual application onto the container. And the git clone, that is actually part of the trigger in the build stage. So when the trigger happens in the source stage, then it actually clones the repo into an artifact. And that artifact is then handed over to the stages. And what we do right now here is we actually get a Python base image, and then we put the source code on it. We put a couple of files into it that it actually works. It's all based on a Docker file that we run here, and then we push, or we tag the image, we push the image to ECR, and then we need to prepare. This one here is the push, actually. This is the push that is happening. So that image is now in ECR. And then we need to do an app spec definition file, which is used for code deploy. So that's a code deploy specific things. And here you see we define the memory, the CPU. We do fetch some secrets to connect to the database. So you see we are using an RDS Aurora, which we have specified which host, which port, which username, which password. So this is all super secure and no passwords lying around, really built on well-architected models. And that's because we are using these service templates, which are built on well-architected principles. And as soon as that is done, the build phase completes, and then we go to the deploy phase. Let's go back to pipelines here. We are looking at the fetch task pipeline in the development area. And then you see it has transitioned into the deploy phase. And now that is where some magic is coming in. That's really cool stuff, which I really love, because we do blue-green deployments for this application for each microservice. So you may remember that we had version 1 running. And so that's the actual application running right now. So this is the URL where the user would talk with the production application. And now, because we are doing blue-green, with the blue-green and in the AWS world, you get something like a hidden port. The hidden port that we are using is actually the same ALB, but it got another port. So you see here port 9000 that is used. And if I refresh here, most likely it still stays on version 1.0. And if I go back into code deploy and we wait here a bit, now you see it is starting. So actually, it has now deployed a second container onto ECS. So if we go to ECS and refresh here, yes, when I refresh here, if I go to services and if I look at the fetch task service, we see here we have 2 tasks running. And the reason for that is I go in here and I go in here. And what I see is, if I make that bigger, what I see here is that I have the old version running, which is version 1.0, and then I have a new container running with version 1.1 in there. So in the current stage, this is still the productive application. I can refresh here. You see it stays on version 1.0. If I go to the hidden port, that should now be version 1.1. Actually, that's the case. So we do have now 2 application versions running in a blue-green environment. The actual application with version 1.0 and the new release, the new commit that I did 5 minutes ago on GitHub, which is running in another container running with version 1.1 with the updated code. And now a really cool thing comes in. This is really easy to use for the developer. Everyone will understand that. Here they can go in and actually test out the application. Or actually, here they can go in and test out the application. And then if they are happy, they go back to the code deploy UI and say, I'm happy. That's a cool new release. I want to reroute the traffic. So what they do is they go in here, press the button here, and I go back now. You see here is not port 9000. This is the actual application. And I'm refreshing here quite often. And it will take about 10 to 30 seconds. Sometimes it is quicker. Now it was really quick. And now you see version 1.1 is live. So now we have switched over. So now the new version is live for the application. The users will hit the new application version. So now if something bad happens, so the testing was not truly enough, they get a call and say, something went wrong, we need to roll back. Then the developer has the ability, with a very easy to use way, and he can stop and roll back the deployment. We are not doing that right now, but because still blue and green are running, the old and the new version are still running, the developer has in that configuration 1 hour to roll back, and that can be any number, of course. So we just have defined it for 1 hour. So the dev could go in here and say, not happy, and we need to roll back, press the button here, and 15 seconds later, it switches back and goes actually to the old version. And that makes the usage of new versions and the rollout of new versions, the deployment of new versions super easy. In this case, we are happy, so the change was successful. We could auto-terminate it. After 1 hour, it terminates automatically to save on costs, because these resources are running, but we are super happy with the release. We terminate the old task set, we press that, and that ECS task will go away in a few minutes. So that actually takes a bit of time because of a graceful shutdown that is happening. So that's not only Proton that you have seen right now, but you have also seen how we are using blue-green methodologies. And because I want to prove you that with the script that I have executed, it's not only showing here the development instances with the pipelines, it has also started to provision the production instances. So if we go in Proton, we should see here now 8 instances. Yes, that's what we see. We see 4 for development, and we see 4 for development. 4 for dev, 4 for prod, all provisioned automatically. We should see a lot more CloudFormation stacks. That's right. So we had about 30 before. Now we got 43. We see now most likely at least 7, maybe even 8 pipelines now. So the 8th pipeline will come in a few minutes, and that was all configured by Proton based on the same templates in a highly parameterized way. Good. And now I have talked a lot. Any questions from your side? I need to take a sip. Yes, somebody's typing. I give a bit of time to see the question. Oh, any disadvantages? Yes, thanks, Graham, for that question. Of course, disadvantages is you have another layer of orchestration. So you need to understand Proton, of course, and there is also a new parametration language with Jinja, that search and replace thing for Jinja. And yeah, that's 2 disadvantages that are coming to my mind right now. But I think the advantages massively outweigh the disadvantages. So from my perspective, Proton is really nice, even if it's quite new. So GA was, I believe, was in May timeframe, but we have used it now quite a bit, and we can confirm that we are super happy with the quality that we have. And if something happens, there is always AWS support, which helps us to get things straight. And as I said before, we do have quite some direct links into AWS Proton development. So we know there are quite a few folks that help us to solve issues if we see them. Good. Yes, Mark, thanks for that question about DB updates and rollbacks. And of course, I have not mentioned that. Of course, if you have two versions of your application running, you need to have a good DB schema management. So, of course, in the new version, you cannot just drop tables from the previous version because you think you don't need them anymore, because with blue-green deployment, you do have two versions running simultaneously for a few hours, and for that you need forward and backward compatible DB schemas. So you need a plan how to do schemas correctly, and I would advise to use something like Firefly or any other DB schema management, so that you also manage your DB schema in a programmatic way. Good. Any other questions from the audience? No, good. So then I think the demo has concluded and everything went well. And here I wanted to show you a couple of products and service offerings that we as Copit do. So we have packaged up a number of our services which make them easy to consume. So if you go onto our website under resources, you find all of these papers and offerings, and we certainly can help you and your company adopting these solutions. So from containers to serverless to infrastructure as code, doing service catalog things, going with Proton, talk to us. We are here. We can certainly help you building those things on AWS, on Puppet, and Kubernetes. We are specialists and can certainly help you there. Good. So actually, timing-wise, we are quite in time. So we are coming to a closing. Thank you so much for spending 45 minutes with us. It's great to see that a number of folks joined here. And as always, we do have a new webinar set up on the 27th of September. That's actually next week. And there we are going to look at AWS databases. So become cloud native, see the portfolio, see in action, and see RDS and other database technologies running on AWS. If you haven't registered yet for our Container Day, also see on our LinkedIn page. So we are having a full day of hands-on sessions on October 5th. Come and join us there. We still have a few places there, but we would love to see you joining us and learn about Kubernetes and AWS Fargate running on AWS. So thanks everyone for joining here for this webinar. It was fun having you on board. I hope you learned something. If you need anything, reach out. We are here, hello@copit.ch, and we look forward to help you in any AWS project or implementation. Thank you so much. Have a great evening. Talk soon, and goodbye.